So this is the structural model. The importance of this is that without it, the building wouldn't stand. So what we have to take into account when making the building stand is the different loads that it's going to experience. So some examples of loads are the loads of people walking through the building, or snow on the roof, or the appliances like air conditioning and those type of things that are on the roof. So we have to figure out a way to transfer the load of those things to the ground. So it starts off with trusses, which are those pieces kind of grown across. You can see them on the roof. And those are steel trusses, and the steel trusses transfer the load to beams, which are the horizontal pieces, and the beams are also steel. And after the beams, the load is transferred to steel columns, and then it goes to the foundation, which is concrete in our case. So this is a close-up of the roof trusses. We needed to pick out a specific truss because different buildings are going to experience different loads, so you need a specific truss. So we start by figuring out what length we have to span. So in our case, this is an 80-foot length. So in all those numbers there, you start by going to where it says 80-foot length, and then you figure out what force is going to be experiencing and the spacing between each truss. So if the trusses are closer together, they don't need to be as big, but then you need more. But the alternative is larger trusses, but then they're more spaced out. So you need to find a balance between those two things to figure out which one is the most cost effective. Next, we're going to talk about a specific structural section, which was a bridge.
So using the program Revit that Taylor talked about a moment ago, I designed a bridge